Okay, so in this question, we have a piecewise function. It's a function which is continuous. That's a big word. Continuous everywhere. So therefore, we can find m. You can see the answer there. How'd they come up with that? Well, the idea behind this problem is that if you have like a graph, okay, and then the function's coming over at let's 2, 3 here at 3. And they're saying when x is less than 3, it does that, whatever that is. So I'll just go make something up. Okay. Now I'm going to put an open dot because it's not equal to 3. Or oh, that's supposed to be -3. What am I doing? I'm off my rocker here. Let's try this again. Okay, so I got a bet. It's -3. Whatever. It's the same concept. Whatever. I'll do it, right? -3. Okay, anyway. So this is left of -3. So to the left of -3, it's actually a straight line. I'll make it more accurate. Straight line going up. So let's do that. Boom. But open dot because it's not equal to -3. So on the left, that's the mx minus 6. Y equals mx. F of x is the same as y. Okay. Goes like that. So heads off that away. And then the other side, this right here is to the right, greater than -3. And it's going to be a solid dot because it's got the solid bar. So what's that? That's a x squared function. You don't have to graph this accurately, whatever. Um, my point is, what if it did this? What if it was like down here, and then did its whatever x squared thing? Yeah, x squared's a U shape. You probably remember. What if it did that? No, you can't do that because that would not be continuous. Continuous means you can't pick up your pen when you're tracing. If you tried to trace this function, you'd have to jump down to here. You have to pick up your pen, right? That's not continuous. So I'll cross that out and I'll say no, can't do that. What does it got to do? Instead, it's got to fill in that hole perfectly, and then it can do its U thing. This right side here, which is whatever y equals x squared, this function, plus 9x minus 3. They have to be at the same height, same y. This solid dot has to fill in that open dot. Why? Because it's a continuous function. So you have to go like this and keep going. You can't pick up your pen. So if you know it's a continuous function. So that's a long story to say this equation, mx minus 6, must equal the other equation, not everywhere, but specifically at x is -3. At -3 right here, they have to have the same y value. They have to. So that means if I plug in -3 there and -3 there and there, they've got to match up. So that means m times -3 minus 6 has got to be equal. Remember, you put parentheses around things you're plugging into functions. And for x, they put parentheses. That's got to be a true equation. They got to match up same height. So then, where'd I go? Now we're going to solve that. So what is that? -3m minus 6 is 9 minus 27 minus 3. Okay, so -3m minus 6 is something. I don't know. What is that? Minus 21, I think. 6, yeah. -21. Okay, and then add the 6 to both sides. And boom, there. -3m is something. I think it's -15, isn't it? Yeah. And then divide by the -3. So m has got to be, it's +5, huh? +5, is that what they said? Yeah, that's what they said. So there it is. The two heights have to be equal because it's a continuous function. So there we go.